Hello, fellow subscribers, Extruded Element users. I am here to show you this video today where I'll be stepping you through the steps to get a 3D likeness model like this one I got from a Fiverr user, Adamaz, and turn it into a very cool hollowed out version so I can save on plastic. This thing is going to be about 1 meter tall, I believe, like on the order of 30 some inches tall. And on one side, I'm going to pass through these really cool Legend of Zelda like elements, extruded elements, and partition it up that way. These elements will then conform themselves to the curvature of the sculpture, and the other half you'll see in the rest of the video will have some more scientific mathematical elements passing through them. So I got this model thanks to Adamaz Ara on Fiverr, Fiverr.com. His username is ATAMAZ. Please solicit him and get sculptures from him. He's amazing. These are the more scientific elements that I'll be using on the left side of my father, where his left hemisphere is more scientific. And then on my father's bust. And please subscribe to the subreddit if you haven't already. Here's project update on the stand-up paddleboard. Just yesterday, it surpassed the height of my daughter, my 5-year-old daughter. It's now at 50 inches. And I added these little support elements that are 33% thicker than the rest of the body, and they're going to go around the perimeter. Those are used because I will be hopping up and on and off the stand-up paddleboard, so I didn't want to ram it too hard and crumple it and have to uncover the clear vinyl and have a massive headache. So without further ado, let's get on with the instructions on how to partition up your 3D model, hollow it out, and put some extruded elements through it. And thank you so much for Angus from Maker's Muse. I needed just a short segment from his video, but he showed us how to hollow it out by going to it's a very simple hollow feature, and you can select the hollowed out thickness, how much solid it leaves around the perimeter. Enjoy. All right, so as you can see in the screen capture here, I'm just narrating its 1.15 scale bust. In this recording, you can see I typed in the file name of this STL of the bust, and he also gave me a STL of the glasses Adamaz from Fiverr did, which was wonderful. There are the scaling factors to get the head and the bust the right size. And then scrolling down here, you can see that there's the only one active executed code line, which is just to import the 3D solid. The import of the solid looks like it just takes a couple seconds, even though it's 2 million faces, which is pretty cool. So here I'm shifting that solid into the first quadrant in the positive X and positive Y quadrant to get the width of his shoulders and to get the height of the bust, the thickness through which I'll extrude. In this case, I'd like to extrude through the side of his head. And now I'd like to make a left and a right hemisphere block such that I can split him down the center. So what I'm doing here is just finding out how wide he is and how wide I need that intersecting block to be. After this, I'll shift him back to center, just like the block just popped back to center there. And I will use only half of the block. Right here, I write the lines to create a cube only on the right side for the right hemisphere and only on the left side for the left hemisphere. So once a left side of the, on the positive side of the x-axis block is intersected with the bust, it'll just give me that side of the bust split nicely down the middle. Then I'll intersect the left-hand side with a large rectangular block. It'll give me just the other side of the bust, the left side. All right, one more sped up process narration here and then the conclusion. So here it partitioned the solid bust, and I just file export to save the STL. And here this is MeshMixer, free software. You go to File, down to Hollow, or maybe it's not File. Anyways, it's in the Edit options, I believe. And you can select the thickness of your hollow. So in my case, over on the right pane, you see 0.4199 was my equivalent thickness. The model scale came in at one scale, and 0.4199 is equivalent to 4 millimeters. That's how thick I wanted it to be. Like, I actually am modeling off of these elements here. So once you get that that hollowed out using MeshMixer, you export it. And here I'm typing in the exported hollowed structure, db_h for hollow, dadbust_hollow. And I press F6, and I just wait a long time. So the next video you'll see is me going live with the results of this. Thank you for hanging out for the project updates and the sped up walkthrough of how to utilize this to partition up a sculpture. So we hollowed out the sculpture. We set it up to be split in half because in this case, I'd like to, in the sculpture, represent the left side different from the right side, because the left hemisphere of the brain is in charge of the scientific and mathematical operations in your brain. So with that being said, here I have the hollowed out structure. As you can see here at the top, it might be covered by my video, but it took about 35 minutes to render, splitting a 2.1 million element or 2.1 million facet STL file in half with a big rectangular block. And so if you check out the subreddit, I'll be using these hexagonal elements for that calculative, scientific, mathematical side of his brain. So I'll be passing these through that side. I might transition into the body to the other element style, because the left side of your brain controls the right side of your body. It's a little confusing. Probably for simplicity's sake, I'll just do these on the left half. And then that was my schedule, because it looks professional, scientific, reminds me of molecules. He is into chemistry and mathematics. And then if we go back to what I'll do the exact same process for the right side of him. Right hemisphere is artistic. And here I will use these triangular elements, element type of 1 and E fill set to -1, so you can lightweight these elements. And I'm doing kind of taking artistic liberties here to lightweight it in a way that reminds me of Legend of Zelda or something like that. So anyways, if you want to learn more about this lightweighting fashion, doing some artistic stuff, I can pass you the code, which is down here in the module called lightweighting. I just made you can pause the video right here and copy this code and learn about what it does. The variables I use there to size these triangles are right there. But anyways, when you make something like this into a tessellation, let's see what it looks like when I make it into a large array, which will pass through the right side of his sculpture. I really like how those turned out. So that's pretty cool. It makes some neat images, kind of mesmerizing. And that way you'll be able to look through that side of the sculpture. That'll be pretty neat. And the backside, you'll see the backside of the other solid hexagonal elements that are more business-like, scientific and mathematical minded. Anyways, please subscribe if you haven't already. Oh, I wanted to thank Maker's Muse. They posted a video, I think his name is Angus, showing me exactly how to use MeshMixer to hollow out a STL file. So please go to Maker's Muse's YouTube video on hollowing out a a file if you want to really reduce the amount of plastic you'll use on a project like this. Thanks a lot, and I'll be updating you soon with further progress. And please, if you haven't done so, go to subreddit Extruded Element and subscribe and follow what's going on. Take care.